We have a MacBook Pro, and this is coming in for backlight issue. So, before we go into this particular device, I'm just going to do a bit of a like a guide or a bit of an introduction when backlight is concerned. So, the most important part of any repair is to understand exactly the issue that you're dealing with, is to be able to identify that indeed this is this and that is that. Because if that's not the case, what will happen is you will apply a methodology of a different problem to something, and then you obviously you get the reverse result, because you have not been able to properly identify or define what the issue is. So if a client tells you I have backlight issue, now what you want to understand, or what you want to get to define it, first of all, you need to confirm that indeed the problem is backlight issue. Now, that way you have to isolate that the problem is not a screen issue. Yeah, you have to isolate that the problem is not a screen issue. And then you again have to understand that the problem is not a lead sensor issue. So what I mean by it being a lead sensor issue is this. So if this device has a lead sensor issue, what it will mean is immediately the device powers on, you will get backlight. But afterwards, obviously, when the lead sensor, when the lead signal sensor kicks in, then the backlight disappears. Which would then mean that what has happened is, say I power on the device, immediately you get the Apple logo. Let's see, which device is this again? Okay, so what will happen is you power on the device, immediately you will get the Apple logo, and then immediately it disappears, and then you have no backlight. Now, that behavior tells you that you do not necessarily have a backlight issue, but an SMC, a lead sensor issue. So what will happen is that the machine powers on, you have backlight, but then when the signal, the lead signal kicks in, what happens is the display blares out. In that case, what has just happened is the device just sensed that the lead itself has been closed, which would then mean that it will turn off the system backlight. So what is most important is for you to be able to define exactly what state the device is in. Be sure that it's not a problem of the screen itself, and then be sure that you don't have an issue with with the lead sensor. Now, and then again, after that has been defined, you then again have to define now when you now go onto the board, if you have properly defined that okay, it's not a screen issue, you do not have a lead sensor issue, then the next thing you now want to now, especially on those devices that have a physical that has a physical lead sensor cable, for example, like the 16 inches, they have the physical lead sensor cable, and that was actually the 16 inches was the first time that Apple had to include a physical lead sensor cable. The previous ones, they didn't have a lead sensor cable, and then obviously it continued with the 14 inches and the 16 inches, the M series. Okay. This one it says that it's a no backlight issue. We are going to go through it step by step to define and to understand exactly what the issue is, and then how to resolve it. So let's see. It doesn't seem to be charged. Let's power the device on. And then another thing is okay. Let's see. Okay, now it's coming on. We getting feedback on the trackpad. And then another thing is whenever they say that the issue you have issues with with backlight, you have to again confirm that indeed you have okay, the device is powered on. And then I don't know if you guys saw that. Okay, yeah. Then another thing you also want to confirm is to make sure that it's not a case of your device not posted. Now, that there are also two of it. So sometimes you have a state where the device powers on but is not posting. If it's not posting, and one of the ways you can confirm that the device is not posting is by using your capacitor, correct? If your capacitor comes on, definitely your device is what is posted. And ultimately, if you have your touch bar being on, definitely the device is what is posted. So sometimes you might have a case of the device itself not being posted, then that is definitely you have obviously if it's not being posted, there's nothing's going to be on the screen. That is one. Number two is sometimes you might also have a case of where the device does not detect, the device is posted but the screen is not detected. Also, when you have a case like that, you have to understand that primarily the screen has to be detected before you'll have backlight. But for this one, we can actually confirm that it's a backlight issue. I don't know if you guys can see the date. We have 1614, correct? You see that? So this seemed to be a backlight issue. The device is posted. We have display, but we don't have backlight. So what we are now going to do is we are now going to, and then another thing I'm also going to talk about, but that's going to be on a separate video, is a case of where you have a case of a flex gate issue. A case of a flex gate issue, commonly you have flex gate issues on A1707s and A1706 and A1708. And how do you identify if it's a flex gate issue? You can identify using your multimeter when you open up the back of the device. You will, when you measure on your backlight output, you realize that the backlight itself is being produced but is not being consumed by the screen because of the screen backlight cable has been partially broken. And then another way you can also confirm if it's a flex gate issue, it's by gradually opening the lead just to see if you can get a connection just like this. See, gradually opening, just so if you can get a, so gradually, but as you can see, there's nothing. Then again, something I want to mention about flex gate issues. Flex gate issues are very common on A1707s, A1706, A1708. A2141 being the 14 inches, it is not common, and flex gates are also not common on the MacBook Airs. It's almost I've on my side, it's very rare to find a MacBook Air that has flex gate issue. It's also very rare to find a 16 inches with a flex gate issue. So that said, let's dig in and see exactly what is it that we are looking at here. So let's quickly take out the back cover. We are going to use a P5 to take out the back screws. You try to make sure you apply a guide to your screwdriver so that you do not scratch the back of the device. Important. You see a scratch like this one, for example. I don't know if you guys can see that. That's a scratch. So some people are very attentive to their device. You don't want to have any scratch on the device, so it's good. You see there's also one here, so it's good that you guide your screwdriver. Okay. Now that our screw, now that that is out, I see that, let's show you guys this. So you see that screw, this screw, and that screw, that and that, it looks worn out, which would mean that it seems they actually tried to probably replace the screen just to be sure that the problem is not the screen. So the next thing we're now going to do is, on older devices, it's very common where they say, okay, let's check the fuse. But on newer devices, especially MacBook Pros, I did a video before where I mentioned that the backlight output from 2013 down to 2019 MacBook Pros, from 2013 down to 2019 MacBook Pros, the backlight output capacitors, they tend to fail very easy. And what happens is, the 2013 they use the same backlight output. 2013, 2014 the same thing, 2015 the same thing, 2016, 17 they use the same backlight output capacitors. 2017, 2018, 2019 they all use the same backlight capacitors output, which means you can obviously you can swap from 2013 up down to 2019. It doesn't matter. Now in this case, so the first thing we are going to do is we are going to, but obviously because this is an A1990. Sorry, this is an A2141, so we are not expecting to have an issue with the flex gate. But if this was an issue with the flex gate, what will happen is, if we measure the backlight output, we will be getting the maximum voltage that is being produced, which is going to be around about 50 something volt, correct? So let's and then we can measure for backlight output here. So we put our black probe on ground, and then our red probe. Let's see. We have 0 on that side, and then on this side we also have 0. So let's just be sure that our multimeter is working. Let's check on our fuse. What do we have? We have 12.6. So that tells us that our multimeter is actually working. So on this side we have 0, and then on the other side we also have 0. Now, in my previous video, I did mention that from 2013 to 2019's MacBook Pros, to be precise, when you have issues on their on your backlight, provided that there is no physical damage, for example, liquid, for example, drop damage, the one thing that you want to do, remember, is to check out this one, capacitors is. Most likely one of the capacitors has shorted out. So the way we're going to do that is now, especially now that we see that we're getting 0 volt on both sides, because also in your backlight repair, you have a condition where your PP bus voltage will be present on your backlight output, which will mean that the device, the backlight is not boosted. But in this case, we have 0, which means there is nothing there. Most likely we have a short on our backlight output. So what you're going to do is we're going to disconnect the charger, disconnect the battery, because we don't want power there while we're making our measurement. Another thing we want to do is we want to press and hold on the power button, which is to make sure that any voltage that is left is also gotten rid of. So we're doing that now. Okay, now, so the next thing we're now going to do now is we are now going to see if we have a short on that line. So we switch our multimeter to diode mode. Now in diode mode, we're going to use our red probe. We will place our red probe on ground, and then our black probe, we'll use our black probe to basically do do the measurement. Now before we do that, let's quickly open up the board view so that we have an idea of what's happening here. So this is an 820.001.700. That's 16 inches, and the capacitors that I'm making mentions of these ones here. These are not they are not tantalum capacitors. Which also which will also mean that these capacitors, they are not they are not basically, in terms of orientation, it doesn't matter how you orient them. You can orient them, which what I mean by that is you have pin 1 and pin 2 here. You can basically switch it to have pin 2 to feed on pin 1, and then pin 1 feeding on pin 2. So these are the capacitors that I'm talking about, that from 2015 from 2013 down to 2019, they use the same capacitors on their backlight output, and they commonly fail. Sometimes you have more than one, but most of the time you only have one of them failing. So the capacitors ranges. So on this board you are going to have, so this is a diode. You see where it says D88410, that's a diode. I'm talking about the capacitors. We see the ones that says C, yeah, so one, not this is L, it's an inductor, correct? So it's 1 2 3 4 5 6 7. On the other side you also have more of it, 8 9 10 11 12 13 14, correct? I'm just going to get another board just to show you. So this is an A1708. So these are the capacitors. So you have 1 2 3 4 5 6 7. 1 2 3 4 5 6 7. Okay, so let's see if I can get another board. Okay, so this is an M1. This is an M1, and then you have the configuration 1 2 3 4 5 6 7, and then you have 1 2 3 4 5 6 7, same configuration. And then here you will have, so this one you have 1 2 3 4 5 6 7, same configuration. 1 2 3 4 5 6 7, same configuration. So you can take from any of this to do your replacement if you find that you have a problem with any of this. But it's very common that one of these fails, and when that happens, what will happen is obviously you get a low reading on your backlight output, and then again what will happen is you have no backlight on your device. So let's see if that's what we have. So let's go back to, so because this is our board, and this is going to be main and this is going to be ground. So you clearly see that. So it says PPV out, SO backlight, and then the other side says ground. So we are expecting to have 0 volt on this side because it's ground. And by the way, you see that they are, if while you're replacing this, for example, if for some reason this joins with this, or this joins with that, or that, do not worry because they are on the same line, correct? You can clearly see that they are on the same line. You don't have to worry. But then it's important that you do a proper installation. But in the case that one joins with the other one, you don't worry because they are what? On the same line. The same thing applies to this, correct? On the ground, other side, they are ground. They are all also on the same line. If they join here also, you don't have a problem. Okay, so now let's see. We have we say because we're measuring in direct mode, our REM probe is going to be on ground. We can use a screw hole here for ground. So this is our ground, and then we clearly see that it's 0. Then the other side, what do we have? We have 0.059. That is too low. 0.059, that is too low. Now, while you are here, there is something else you have to take note of. While you are here, do not quickly jump into removing your board. The next thing you want to do, you see that it is low, correct? What you're supposed to have is, you remember what you're supposed to have? No, 1 point something. Yeah. So, so if we use this, for example, remember because they are same configuration. So, oh, but yeah, by the way, you see that the backlight chip is not here, but fine. So let's see what you're supposed to have here. OL, okay, let's take this one. This one has, okay, this has his backlight still there. 1.2. Why some number 1.2? Yeah, that's what you're supposed to have, correct? Okay, so now when you measure and then you realize that you're getting lower than what you're supposed to get, don't get excited by removing the board. The next thing you want to do is you want to disconnect the screen. Of course, sometimes remember that if you see that line, sometimes you may have a problem on this. You may have a problem which is from the screen, and that can affect your what? Your backlight output. So what you're going to do is, before you worry about removing it, you want to first of all disconnect your screen and then measure again. If after disconnecting your screen cable and you still have low reading, then you know you have a problem with one of the capacitors. And 9 out of 10 is one of the capacitors. Do you understand? So next thing we're going to do is to disconnect the screen. So screen is disconnected. Now we check again. This is ground on the other side. Okay, that is good. I actually remember when we started, we said we saw signs that the screen was disconnected, which was very which would mean that they most likely use another screen to test, and then they still found that. So now that we now with the screen cable disconnected, we check and we still have low reading. It means our problem is on the board. And like I said, 9 out of 10, the problem is going to be on one of the capacitors. So the next thing we're going to do is we're going to quickly remove the board. To obviously ascertain which of the capacitors has failed. And I can tell you 9 out of 10, it's one of those capacitors. Now, while I'm busy taking out the board, you can ask questions and then I can explain, so that if you have anything so far that you don't understand, and especially the process in how you define. You see, the most important part of this is you need to define your problem. You need to have a system that you follow. Do you understand? Because if you don't have a system that you follow, you don't. And then another thing is you don't use the same methodology across all. Okay, no backlight. Okay, replace a fuse. Because replacing the fuse on backlight machines was a very common thing back back in the days. It used to be like, oh, you have an issue with your backlight. Okay, replace your fuse. That used to be a very common thing. Now, the backlight fuse. No, not the PV bus fuse. Backlight fuse. Remember when we were talking about fuse? I told you have a PV bus fuse and then you have the backlight fuse. Yeah. So when it comes to repair, you really have to, whatever it is that you're doing. If you take in the device for any type of repair and then they tell you, okay, XYZ needs to be replaced, let them tell you why it needs to be replaced. We need to replace your screen. Why do you need to replace the screen? We need to replace your backlight chip. Why do you need to replace the backlight chip? So basically, they need to give you a why, which is there has to be a detailed troubleshooting that has been done that's in place to kind of to tell me why you're doing what you're doing. You just cannot just do without knowing exactly why you're doing what you're doing. So far, do you have any question that is not clear? Oh, by the way, when I was talking about the angle sensor cable, I was talking about this, the angle sensor cable. So that was what I was talking about. You do know the angle sensor cable, correct? Okay. Yeah, do you have any questions so far? Is it uh, clear so far? So, and then to repair this, there are two ways you do it. You can just remove, you can just replace the whole capacitors. Just save your time. Just you can now the board is out. So there are two ways you can do this. You can literally go through. Um, so sometimes some people they inject voltage. They inject voltage and whichever of the capacitor that glows, obviously through your timer, you can clearly tell that that has failed. That's one way. Another way is you can just remove them by just the whole seven on the side and check to see if you have same reading. And then if not, and then you just replace them, which means your problem is solved. Or you just if not, then you go and remove the other seven from the other side since you have 14. But another thing you can do is we can also look to see if any of it looks, uh, a little bit off in a way. This marking that you see here was done by us so when we were doing the measurement, so that's definitely not it. See, sometimes you might actually see an actual crack, um, but other times you kind of have to. Sometimes you also have to guess. Remember, there was a repair that we did that you had to guess. You remember that repair? That you had to guess which one to, yeah. So where do we start from here? Because I don't see any cracked capacitor, but like I said, definitely is one of these capacitors. So it's not anything outside now. It is one of these ones, one of the 14. So it's one of this, definitely. And the reason why I'm saying definitely is because of um, the particular type of failure that we have in here. It's very common on devices from 20, especially devices that uses these capacitors. It's very common on them. So tell me, where do we start? Do we start from these guys or the ones on the back? The ones here or from the back? You sure we should start from here? Because I'm saying start from here. I don't know. So you want us to start from here? Okay. I'm saying start from back, but yeah, let's do what you want us to do. Let's just again confirm. So we have our red probe on ground and then our black probe. That's supposed to be our main line, and then we have 0.059. Okay, so Shahid say we start from this side. So let's do that. Okay. So what we are going to do is we are just going to go ahead and remove the entire seven on one side and see what happens. Measure again. Hopefully Shahid is right, and if not, we'll have to go to my own side. Okay. And then another thing also, if you also want to waste your time, not a waste of time, but another way you can do this kind of like take it off one by one and then measure, take out one and then measure, and then another one and then measure. But yeah, we can also do that, but just that takes. And then another way you can also do it, which is what we are going to do, is just going to remove the whole of it and then measure the capacitors themselves, not the board, measure the capacitors. Do you understand? Yeah, and then whichever one you get a reading across is the faulty one. Okay. Okay, so the next thing we're going to do is we're going to read across. So we could just go ahead and just read on the read the board now, but we're not going to do that. We want to check the capacitors to see if any of it will give us a read across it. So the first one, no, OL means the capacitor is fine. The next one, let's see what do we have. OL means capacitor is fine. So we're looking for the one that will give us the similar reading we were getting on the board. Do you understand? So let's see this OL, that's fine. That OL, that's fine. And this OL is fine. And then this OL is fine. And then the last one, OL is fine. So now, no, it's supposed to be, yeah, 7. Yeah, that's the whole 7. Let's just try again. So OL, that's fine. Oh, across it. It's OL, that's fine. It's that. OL, that's fine. And then this OL is fine. OL is fine. OL is fine. OL is fine. So most likely the problem is on the other side. So let's check the board now. And then this side, so I think that's supposed to be ground, and then that is supposed to be, yeah, we still have a problem. 0.105 still low. So which means the problem is still, is it increasing? Nah, still 0. Yeah, 0. Yeah, still, yeah, it's still low. Okay, so it means none of these capacitors are faulty. So we are going to put this back and then take out the ones on the other side. So let's put this back. I'm just going to put them and then flush them in place afterwards. Okay, so next thing we're going to do is do the same thing that we did here, which is remove all of the ones at the back and do the same measurements. That looks a bit off, but I cannot confirm yet. Okay, is that out? Let's do the same thing. Let's check. So let's check this one first. What do we have across? OL, that's fine. And then this one, let's see, what do we have? OL, that's fine. And then that, OL, that's fine. OL, that's fine. OL, that's fine. OL, that's fine. Which one? This one? Okay, that's our problem. Okay, so that, you see, that's our problem, that guy. Let's just see, let's read it again. See that? That's our problem. See? It's supposed to be OL just like the rest. And wait, did it now become OL? Okay, yeah, that's our problem. Now, why is that our problem? Now, this is a capacitor, correct? And the capacitor will have two distinct sides, yes, A and B. Now, in between, you will have a material which is basically which will form a separation between area A and area B. Now, what happens is when the capacitor fails, area A becomes equal to area B, which is now, depending on the proportion of the failure, that will determine the numbers that you get. If we were getting like complete 0, that would mean that A is it's completely equal to B. But in cases where you have some numbers not completely 0, that tells you that it's a failing, but it's But obviously, again, it's failed in a way that we still cannot use it. You understand? So that's I mean, that's a capacitor. Unlike an inductor or resistor where you have A, it's somewhat equal to B. A capacitor is not. It's not designed to be like that. So this is our problem. And if we now measure our board, we should have what we are supposed to have. So let's see, it's supposed to be ground. And then the other side, what do we have? We have 1 point. Yeah, so 1 point. So we're going to, once we put those capacitors back, we should have around about what you're supposed to get. So that is our problem. So the next thing we're just quickly going to do is put back the capacitors. We are going to grab one of those capacitors from any of those boards that we had brought out, and that's the repair, and we are good to go, and we're going to test it and finalize it. We are just going to do the testing just to confirm that yes, indeed it works, and leave Shahid to put the device together. So we can grab one from here to uh, taking too long. uh Okay, so this is the one, correct? So put that aside. Okay, so that's it. And the next thing we're going to do is to clean that section of the board. You always make sure that you clean your board after. Clean this side first. Okay, see guys, so that's done. We are now going to test. So when using a sharp object like this one, be very careful around the battery cells. You don't want to punch the battery cells because doing so will damage the battery. So it's you actually use whatever sharp object that you're using. Be very much aware that you are fully in control. Even a screwdriver, when you are scrolling or unscrolling around your battery, you want to make sure that you have full control because you don't want to punch a hole on any of the battery cells because that will render your battery dead. Okay, so let's see that. We are only going to connect the cables that we need to do our testing. We don't need that, so we need the screen to test. We don't need trackpad, but we're just gonna have the trackpad added. Keyboard, even though we don't need that for the actual testing, but we're just gonna have that also added. Please note that the keyboard is not going to work if you don't have the trackpad connected. Okay, we don't have to connect the battery because we have enough juice from the charger. This takes a 19 volt, so we have a 96 watts to yeah, it takes a 96 watts, so we have a 96 watts. So so if you don't have the rated charger, then you need a battery in order for you to have a power balance. But if you have a rated charger, then you can use a charger without having to. Some of them, some you might find some devices that will obviously require you to have the battery and charger connected, but this particular one you do not need the battery, especially provided you have the rated charger for it. So we are not going to connect the battery because we have a rated charger for it. We are only connecting the cables that we need to test the backlight. So we have the screen connector. We have that's basically all you need. So the screen and then obviously the DC jack. But then in case we need to put in a password, that's why we have the trackpad connected as well as the keyboard. The reason why we have the trackpad connected is because the keyboard is powered through the trackpad. Okay, so now let's now we can also put one speaker on just to get the feel when it starts. Or we can just have both speakers on. Oh yeah, there's one cable that we didn't take out there for the mic. Yeah. Okay. Let's do that. Okay. We have trackpad feedback. We have trackpad feedback. Waiting for it to start. We have a chime, and that's a beautiful Apple logo. And then, as you guys know before, now we didn't have an Apple logo, and then now we do have an Apple logo. Okay, so let's quickly go over the steps. So what did we do? So the first thing we had to do was we had to define the state of the device, which we confirmed that indeed it's an issue for of no backlight. The next thing we had to do was to take out the back cover. Taking out the back cover, we had to try to isolate the issue first of all by having to measure to see what is it that we have on our backlight output, and if we get it zero on our backlight output, obviously with the device booted and powered. As you know, the backlight output is only going to be present if your device is started. I mean, if your device is in SL state. We checked that and we're getting zero on our 0 volt on our backlight output. Then the next thing we had to do was to disconnect power from the device, and then we checked to see if we have a short on our backlight output. Why we did that was because I said on the MacBook Pros from 20, especially the ones that utilizes this configurations of capacitors. By the way, this configuration of capacitors, they likely most of the time you find one or more failing. So and this the A2141 is one of the ones that uses that configuration of capacitors on their backlight output. So we measured and then we found that we have a short on our backlight output. So through those capacitors, we assumed The next thing we had to do was, before we continue, we had to make sure that we disconnect the screen to confirm that the problem is not from the screen, because sometimes you might have a short on our backlight output, but it is actually from the screen and not from the capacitors. And then we checked, and then we were actually hoping that it's not from the screen because it makes the repair more expensive. When we checked the problem was not from the screen, then we now had to remove the board, and then we start by removing the first seven setup, and that was not a problem. We went to the other side, we removed the second seven setups, and that's where we found one of the capacitor that actually failed. And then what we had to do was to determine if a capacitor was to read across the capacitors itself. Given the nature of a capacitor, when you on diode mode, if you're using continuity mode, when you place both probes on the faulty capacitor, it should beep. When you are on your diode mode, you should have numbers that is to tell you you have a problem, or else to tell you that you don't have a problem. So we checked, and then we had all else across except one, which was 0 point something, and that was almost like the reading that we were getting on the board itself. So we replace that, and then there you go. And then you say that you can take that capacitor from anywhere. And also, if you don't have the capacitor at all, you can leave it. You can work with 13, and then you also be good to go. That's about that. And then I will see you guys in the next one, unless you have any question.
You don't, so say for instance, maybe two of it that the problem can you still.
Yes, yes, you still can. Yeah, that's it. Okay, thank you guys. I will see you guys in the next one.